Bismillahirrahmanirrahim. Dear students, with another lecture of C.I.T. 214 Electronics 2, I am here, and today we will discuss on the IC shift register. Before this, we were discussing on the on a simple D-type flip-flops combinational design circuit that was combinedly making a shift register. But right now we have, as per the electronics advances, we may come to know that the larger circuits were summarized into smaller circuits in the form of ICs. ICs stands for, as you know, integrated circuits. So here is 74195 IC. 74195 IC is basically a 4-bit shift register. How it works, what are its functions. Today we will discuss on that. Before going to this, we have a short description on this, that is 74195 IC is basically a 4-bit shift register. It is used for a parallel load. What it means that it loads the data parallelly, and we have a data in the form of JK flip-flops procedure. Okay, let us see over here on this. I have a quick view on this IC circuit. What is it as per its construction? We have this IC structure. Pin number 1 is for clear. Clear means that when all the data of loaded to 111, then clear bit will invert it into the form of 000, which means that the clear data resets the data, or this pin is used to reset the values at any stage. The second pulse number 10 is the clock run pulse. Basically, this pulse, this pin is connected with the clock pulses. As you know, that clock pulses are 1 or zeros, pulses of plus 5 volt. Pin number 9 shows SH slash LD, which means that shift or load. We can shift the data through it 1, 0, or we can change the data at any condition, or we can load the data at any stage through 1, 2, 3, 4. These 4 inputs. These are the 4 data inputs where we load our required data. That data may be anything, 000 or 001 or 0101 or 111, anything that you want to load, you can load on these 4 pins. Pin number 8, pin number 8, G and D. G and D stands for ground. This pin will be grounded. And here are the data output pins, QA, QB, QC, QD. These 4 are basically the output, data output pins where we take our data output. And QD hash is basically showing the complement of QD, which is pin number 12. Pin number 11 is basically pin number 12's complement, which is used to regularize the inputs at any stage. Pin number 16 is showing VCC. VCC means the voltage from the source which are supporting this IC to work, operationally work. As we have discussed now on the construction of this circuit, now we will discuss on its working, how it works, how it functions. So here we have a function table which will easily give you a description that how 74195 IC shift register works. First is clear, the second is shift to load, that is shift to load comes from here. Clear comes from this pin number 1. Clock comes from the pin number 10. We have clock, and then JK is basically showing these 2 inputs, J and K. JK are the serial inputs. This is pin number, these are the pin number 2 or 3. These are the serial inputs. Basically, they are working like JK. JK flip flop was basically a flip flop that was working in toggle mode. as we discussed in previous chapter. Serial inputs are basically these four serial inputs. We will discuss on this. And function, what was the result of that output that was taken parallelly. So when you apply a clear 0, there is no shift load, no clock pulse, no serial input JK, or there is no serial input. It means that this function is known as asynchronous clear. On second stage, we have higher or plus 5 or 1 at clear, no shift load, zero clock pulse, there is no zero clock pulse level, so there is no JK action and there is no serial input, so there is no change in output. There will be nothing on the output. Now, once again, function number 3, we have clear at 1 and shift load is 0, clock pulse is higher, then there will be no change at JK or serial input. So we have to load input data. This means that we have to load the input data. So here we are going to load the input data. 1 is at clear, 1 is at shift mode, clock is 1. So JK flip flop will toggle the mode and it will convert that data from 0 and 1. 1 is at serial input, and as a result, what will happen? It will simply happen that it starts from QA towards QD, data flow. QA to QD, the data will travel. When data will travel through these inputs, what will happen in the next stage? It starts serial input 1. Now, when the data is here is 1, shift load is 1, and we are loading 1, we have a clock 1, then JK will become 1 because it is a toggle mode, it will be 1 and serial input will be also 1. So it simply means that it starts shifting data from QA towards QD, and we have an inverted data that is basically 1 at the output. And at the end, we will send a clock pulse to the clock pulse to add this description, which will abandon the all the procedure, and once again from 1 this whole data will be reset and the function will repeat its process again and again till we close this program close the current provision through this positive VCCC or load, source load. I'm hopeful that you may have understand this lecture, and if you found any kind of problem, you may ask me on my WhatsApp number or Google Class. Thank you so much. Stay safe, stay home, and happy winter season. Thank you so much.